the fasted state and the starved state. This is the last of your metabolism videos. So in the last video, we talked about the absorptive or fed state and how primarily what happens with the fed state is you are going to do a lot of anabolic processes in which you are storing things. You will have used whatever you needed, and then you can store the rest. And you can store the rest as glycogen. And then if you still have extras, we know that you can store some as adipose. And then if you needed to, you could do protein synthesis, although that's not controlled by insulin. Okay, so now what we want to talk about is how do you maintain your nutrient levels in your bloodstream when you haven't eaten anything for 8 to 12 hours after a meal. So we're going to do the same thing we did last time. You've got this in your notes, and then I've got a bigger one over here. I'm going to draw on this, and you can fill this in your notes. So what is going to be happening during this state? Let me blow this up so I can draw on it a little more easily. And so first thing is we need to acknowledge that basically the small intestine is pretty much going to be empty. So you got no goodies in there, okay? But we know that we still are going to need glucose. Primarily we are going to need it for the brain, but also for other places. So what's going to happen is, hopefully it makes sense to you, that we're going to have a pretty low level of glucose. Okay, and what's going to happen is the pancreas is going to detect that low level of glucose, and it's going to respond by releasing a different hormone. This time insulin would not help, so we are going to release glucagon. And remember, my way of remembering it is that you release glucagon when your glucose is gone. And what glucagon is going to do is go multiple places, but one of the places it's going to go is the liver. And when it goes to the liver, it is going to cause the breakdown of glycogen back to glucose. And then what am I going to do with the glucose? Well, I'm going to send it to the bloodstream. And then what gets dibs on it from the bloodstream? Well, the brain is going to get first dibs on glucose, and it's going to use that glucose to make ATP for the brain cells. So now we've got a happy brain. Okay, so what about other organs? Well, this is an oversimplification, but I will tell you that during the fasted state, if you can get any other organ to use something other than glucose, then the brain gets more glucose for itself. So one of the ways that you do that is to force other tissues to burn fats instead. And you can do that by breaking down adipose tissue. And of course, breaking down adipose tissue is called lipolysis. And you break it down primarily to triglycerides. And then we know you can send triglycerides to cells. They can break it down to glycerol and fatty acids, and then you can do cellular respiration with fatty acids. Okay, two last things here, and then we'll sort of wrap it up with the fasted state. First off, remember when things were good, we stored glycogen in skeletal muscle, but now times are tough. What do? Well, the skeletal muscle does not play well with others. So even though it has glycogen and it can break it down to glucose, it keeps the glucose and uses it for itself. So importantly, it does not, so I'm going to draw this and then erase it. It does not dump that glucose into the bloodstream to share with other organs in any great amount. So one last little thing. What about gluconeogenesis? If you really start to run out of sugar and fat stores, but you have protein stores, the liver can actually take amino acids and make them, I'm going to abbreviate these, into glucose. And when it makes it into glucose, then you can take that glucose and dump it into the bloodstream as well. But this right here, gluconeogenesis, let me write it down. Genesis is not plan A, even when in the fasted state. You're going to break down other nutrients first. Okay, so what is the big picture understanding that we've got here? So all that we've been talking about in this portion is what we call the fasted state or the post-absorptive state. And in the post-absorptive state, the big picture understanding is really what you are doing is catabolism, not anabolism. Catabolism. Okay, and catabolism is, remember, primarily breaking larger things down to smaller things, big organic molecules to smaller organic molecules. And the two biggies that I am going to do in the fasted state is glycogenolysis and lipolysis. And then, if necessary, I will also do gluconeogenesis. And all of this, one more time, is under the presence of that hormone, glucagon. Okay, so last thing is, what about the extreme, when we are in what we call the starved state? And I don't have a whole diagram for this. The starved state is when you are in very, very long periods without glucose, let's say 48 hours or so. And either you can do this intentionally or you just can't get to any food. So what happens then is that you can start getting into the next stage. And the next stage is when you start breaking fatty acids down to ketone bodies in the liver. Again, the liver is all up in metabolism's business. This process is called ketogenesis. And remember, I can use those ketones as a partial substitution for glucose for brain cellular respiration. And the idea here is if I make fatty acids instead of proteins, instead of my muscle proteins, into glucose or into ketones that the brain can burn, I can do less gluconeogenesis of my own skeletal muscle and therefore preserve my own proteins for a longer period of time. So that's ketogenesis. Then, if necessary, will you ever eat your own muscle rather than starve to death? Well, yeah, you will. Muscle protein breakdown will start occurring. This is generally after weeks of starvation, depending on how much you had stored of the other nutrients. Then what's going to happen is you'll start breaking down your own skeletal muscle, and it will be broken down in relatively large quantities for big amounts of gluconeogenesis. Now, sometimes I do gluconeogenesis when I'm in the fasted state, but that's with circulating proteins from my diet, not me eating myself. Okay, but when you get into the starved state and you start running out of fatty acids to do ketogenesis, then you'll start doing gluconeogenesis of your own skeletal muscle. And that's metabolism.